All right, we just finished example 2, which was a compound and inequality. Let's try 2 or inequalities. You're going to notice on your note guide you only have B. So you need to write in A and split that section in half because we're going to do 2 right here. So maybe pause if you need to pause it to write down A. We're going to solve A first, and then we're going to move on to the second part, B. When you're solving an or inequality, guys, you can't glue these together. You cannot just have one inequality where you show me the steps on all 3 parts. You have to just solve each part separate. So we're going to have 2 pieces of work for this problem. Just focus on one at a time. On the first one here, I would want to combine my like terms. Notice I have a variable on both sides, so let's get them together. If I were you, I would tell you to take it to the side where there's more. So here I have 2s, here I have a negative 1s. I'm going to add s to both sides. That way it stays positive. We have 3s is less than 18 now. To isolate my variable, I would undo multiplication by dividing by 3. And I have s is less than 6. For the second part then, similar style. Notice you have s's on both sides. I have 5s over here, so I'm going to subtract this s so that I can have a positive s value remaining. Greater than symbol and 36. Get s by itself by dividing by 4, and you have s is greater than 9. Your final answer then, guys, you have to pull these next to each other. S is less than 6. And you have to keep that word or, so drag that down. Or s is greater than 9. Remember, or is the union. That means it only has to satisfy one of those inequalities. So when you're graphing, keep that in mind. It does not have to be a solution to both of them. I'm going to get my number line set up. Here I want all the numbers that are less than 6, and I'm not including 6. So I'd be shading to the left. And for the second part, I want all the numbers greater than 9, not including 9. So I'd be shading to the right. Box that in, your inequality with your graph. There's your solution region. For part B then, this one's going to look a little bit different. I'm warning you now. There's kind of always these special cases or weird cases that come out. I'm telling you that this is going to be one of them. So if you want, pause the video, solve through it without me, and then we'll look at our graph together. Remember, when you solve these, you need to separate it, keep them separate. You have 2 to work out, and you're going to have or to drag down at the bottom. To get x by itself here, I would add x to both sides, and I'm left with 9 is greater than or equal to 6x. Divide by 6, and I have x is less than or equal to 3/2. I'm going to turn that around, so I have x is less than or equal to 3/2 written this way. On the next part, combine your like terms. I'm going to subtract 20 from both sides. I have a negative 3x is less than or equal to negative 3. Divide both sides by negative 3. And you have x is less than or equal to 1. Oh, I made a mistake. Hopefully you guys are yelling at me. I need to flip that sign. When you divide by a negative, flip it so now it's x is greater than or equal to 1. Pull that down next to my or. Now let's think about this. Zero, 1/2, 1, 1.5. And 2, so forth. If I have all the numbers that are less than 1.5, I would have a filled in circle here, and I would be shading to the left. But if I have x is greater than or equal to 1, I would have a filled in circle here, and I'd be shading to the right. This is an or, which means if it satisfies either one of the inequalities, it is a solution. So what does your final graph look like? What is your answer here? If it can be either one of these, notice you have a shading all the way across. That is your solution graph. It would be the whole number line. So I'm going to redraw it. You really don't need any filled in circles. What you would want to do is draw a line above it the whole way across. That's showing it can be any real number. So that's kind of a special case. Here's your final graph. And here's your final inequality. So if you need to pause, kind of correct your work here, make sure you have this final graph. It can be any number because it's an OR. Last example then, guys, write a compound inequality from the given graph. Since this is a solution region, would this be an AND or an OR? Since both of them are on the graph, it must be an OR because I can't satisfy both of them at the same time. So I'm going to look at this side and say x is any number greater than or equal, greater than not equal to. X is any number greater than 5. And I'm going to look on this side and say x is any number less than or equal to 0. Since it's an OR, you can just leave it like that. If it was an AND, you'd want to glue them together. And a nice little riddle for you guys. How does a math teacher get a compound fracture? She breaks her hand. That's a good one, I know. Her hand with the word and because it's a compound fraction. Just a little chuckle for the rest of your night. All right, bring your questions tomorrow. Don't forget to do your exit ticket after this video.